Hello students, in today's video we are going to discuss about enthalpy, an expression for enthalpy change, relationship between enthalpy change and change in internal energy, and finally work obtained in chemical reaction. First of all, we will discuss about enthalpy. It is denoted by symbol capital N. What is enthalpy? Sum of internal energy of a system and energy equivalent to PV1 is called enthalpy. Sum of internal energy of the system and energy equivalent to PV1 is called enthalpy. Mathematical expression or enthalpy can be given as H is equal to U plus PV, where H is enthalpy of total heat contents of the system, U is internal energy, and PV is work, mechanical work done by the system or on the system. Then it can be explained with the help of some points. Enthalpy is sum of internal energy and PV work. It is a state function. Enthalpy is a state function because its value or magnitude depends only upon initial and final states of the system. And not upon the path followed between these states. Being a state function, exact value of enthalpy cannot be calculated. Hence, change in enthalpy denoted by delta H is taken into consideration. And it is given by this equation: delta H is equal to H2 minus H1, where H1 is enthalpy of the system in initial state, and H2 is enthalpy of the system in final state. And delta H is change in enthalpy. Difference between enthalpy of the system in final state minus enthalpy in initial state is called change in enthalpy. Then we have to discuss about expression for enthalpy change. By the definition of enthalpy, we have S is equal to U plus PV. This is suppose equation 1. Here as U, P and V all are state functions, H is also a state function. Change in enthalpy delta H is given as delta H is equal to H2 minus H1. This is equation 2 where H1 is enthalpy of the system in initial state and H2 is enthalpy of the system in final state. Now, for initial state, equation of enthalpy can be modified as H1 is equal to U1 plus P1 V1. This is equation 3. And for final state, equation of enthalpy can be written as H2 is equal to U plus P2 V2. This is equation 4. Now, if you substituting values of P1 V1 and P2 V2 in equation 2, we get delta H is equal to, now what is value of H1? It is U1 Here we have equation delta H is equal to H2 minus H1. Now you have to substitute value of H2 from equation 4 as U2 plus P2V2 minus into bracket value of H1 as U1 plus P1V1. Now you can modify this equation as delta H is equal to U2 plus P2V2 minus U1 minus P1V1. Take similar terms in one bracket. You will get delta S is equal to U2 minus U1 plus P2V2 minus P1V1 in another bracket. Now change internal energy is given as delta S is equal to delta U plus into bracket P2V2 minus P1V1 at constant pressure. P1 is equal to P2. Say it is P. Then you get this equation like this. Delta S is equal to delta U plus into bracket PV2 minus PV1. Take P common. Then you get delta S is equal to delta U plus P into V2 minus V1. Now V2 is final volume of the system and V1 is initial volume. Difference between final volume and initial volume is change in volume, and we get as V2 minus V1 is delta V. We get delta H is equal to delta U plus P delta V. This is mathematical equation. Now delta H is also heat absorbed by the system at constant pressure. That means as delta H is QP, we can write this equation IO as QP is equal to delta U plus P delta V. This is also an expression for enthalpy change. Here, one important thing we have to discuss about QP and also QV are state functions. But simply Q is not a state function. Question may be asked, which of the following is state function or which of the following is not a state function? In this respect, this information is important. This is about expression for enthalpy change. Now, next point we have to discuss about, and it is relationship between delta H and delta U for chemical reactions. Relationship between delta H and delta delta U in or chemical reaction. At constant pressure, delta H and delta U are related as delta H is equal to delta U plus V delta V. This is suppose equation 1. In case of reactions involving solids, and liquids, there is no change in volume. There is no change in volume, or there is very small change in volume. That is, delta V is almost equal to 0, and therefore in this case delta H and delta U are same. But for reactions involving gases, there is a change in volume. That is, delta V is not equal to 0. In this case, we can have a relation between delta H and delta U like this. Delta H is equal to delta U plus V delta V. Now, this equation can be modified further as delta H is equal to delta U plus P into V2 minus V1. Again, it can be modified like this equation: delta H is equal to delta U plus PV2 minus PV1. This is suppose equation 2. Now, here V1 is initial volume of the system and V2 is final volume of the system. By ideal gas equation, or n number of moles, we have PV is equal to nRT. This is suppose equation 3. This equation can be modified for initial state as PV1 is equal to N1RT. This is equation 3. And for final state, as PV2 is equal to N2RT. Equation 4. Now, if you substitute values of PV1 and PV2 in equation 2, we get substituting values of PV1 and PV2 in equation 2, we get delta H is equal to delta U plus what is PV2? N2RT minus what is PV1? N1RT. Now you can modify this equation as delta H is equal to delta U plus into bracket N2 minus N1. RT is common. It is taken out of the bracket. Now N2 number of moles of the system in final state and N1 number of moles of the system in initial state. Difference between number of moles in final state minus number of moles in initial state is change in number of moles or gaseous system delta Ng. If you substitute this value here, you can have delta H is equal to delta U plus delta N G RT. This is mathematical equation which shows the relationship between delta H and delta U for chemical reaction. Now here to solve the problems, delta Ng is very important. If a balanced chemical thermochemical reaction is given and you have to calculate delta N from that balance equation, for that purpose this equation is very important. Delta Ng will be equal to total number of moles of gaseous products minus total number of moles of gaseous reactants. This formula is very important. Using this formula, you can calculate change in number of moles for the given balanced thermochemical reaction. This is about relationship between delta H and delta U for chemical reaction. And last point we have to discuss about it is work done in chemical reaction. Expression for work done in chemical reaction. Now work done by the system at constant temperature and is given by the equation as follows. W is equal to P external delta V. It may be minus or plus depending upon type of process. If process is expansion, W will be negative, or if process is compression, W will be positive. Assuming P external equal to P. Here pressure P is pressure of the gas and P external is external pressure. They are balancing one another. If one is positive, other will be negative. Here we have taken P external positive. That means P will be negative. Then we have above equation as P is equal to minus P delta V. Here as P external and P are acting opposite to one another. We can change the signs of P external and P, and then we have W is equal to minus P delta V. If you modify this equation as W is equal to minus P into V2 minus V1. Delta V is difference between final volume and initial volume of the system. Therefore, we have this equation. Again, you modify this equation as W is equal to minus PV2 plus PV1. Then, by ideal gas equation, for m moles, we have PV is equal to nRT. Now this is equation. Suppose this is equation 1, this is equation 2, this is equation 3. Now for initial state, we have this equation as PV1 is equal to N1 RT. This is equation 4 at constant pressure. And for final state, equation is written as PV2 will be equal to N2 RT. This is equation 5. Now if you substitute values of substituting values of PV1 and PV2 in equation 2, we get W is equal to, now what is value of PV2 N2 RT minus N2 RT plus value of PV1 as N1 RT, or it can be written as minus into bracket N2 minus N1 outside the bracket RT. This equation is written directly. First of all, change the signs. and you will get this equation, and finally you will get minus delta Ng RT. This is equation 6. This is mathematical expression for work obtained in chemical reaction. Here W depends upon change in volume. Although change in volume is not seen in the equation, but actually it depends upon W depends upon delta V. Now three important informations we have to. If N2 is greater than N1, then delta Ng will be equal to N2 minus N1 will be positive. Then work will be less than 0, that is W will be negative. Second point, if N2 is less than N1, then delta Ng will be equal to N2 minus N1. It will be negative. Then W will be greater than 0, that is W positive. And third point, if N1 is equal to N2, then delta Ng means N2 minus N1 will be equal to 0. Then W will be equal to 0. Thank you.